So why do we have to practice all this factoring anyway? Well, the whole purpose of factoring is to find where the polynomials cross the x-axis. What we're looking for are our x-intercepts, also known as zeros. Okay, so in order for us to find the zeros, we need to use factoring as a method, and this is where you start using factoring to solve equations. So we're not just factoring for factoring's sake. Now we're actually solving equations that we do. So the ones that we're going to work on today are all going to be equal to 0 already. They're going to be set up that way. But in pre-calc, most times you're going to have to get it equal to 0 first. But for today, I set it up for you. You are going to factor using the methods that we practiced, but keeping the equal 0 at the end after your factors. And then you're going to set each factor equal to 0 and then solve each mini equation for x. What this is going to do is give you your solutions. This is the solution to the polynomial. This is where it crosses the x-axis. Those are the zeros. They're all important things, also called roots. So let's take a look at an example and we'll get started. Our first one is 12x squared minus 20x equals 0. This is an equation, and that means that we're going to solve this by factoring. But before we can get our x values, we need to take a look at what kind of factoring we're going to do, what method we're going to use. So it's got two terms. Well, that means it's either a difference of two perfect squares or GCF. Do you see a perfect square anywhere? No, me either. So this is definitely a GCF. So we're going to take out the highest number that divides into both things, which is 4, and the lowest exponent of our variable that both of them have, which is x. And one set of parentheses. And don't forget the equal 0 at the end. That doesn't poof go away. That's all part of an equation. We're going to divide this nicely, and we're going to get 3x minus, we're going to divide that nicely and get 5. At this stage, we're at the factor and keeping it equal to 0 step. Now we're going to set each factor equal to 0. So underneath here, we're going to have 4x equals 0, and we're going to have 3x minus 5 equals 0. We're going to have two little mini equations, and we're going to solve each of them for x. In the left one, I'm going to divide both sides by 4, and 0 divided by 4 is 0, and x is 0. That is an answer. That is a solution. Make sure you include that as an answer. For this one, it's a two-step equation, so I have to add 5 to both sides. And then I'm going to divide everything by 3. And I'm going to get x equals 5/3. So for this equation, this is a quadratic. I'm solving this quadratic. There are two solutions. Notice two solutions, x equals 0 and x equals 5/3. The second example, okay, so this was our GCF example. Solving using GCF. Let's take a look at the second one. Second equation I have is 2x to the third, love those cubics, minus 98x equals 0. Okay, so this is another two-termed expression with an equal sign. And that means that we're either having a difference of two perfect squares or a GCF. I don't see any perfect squares here, so I'm going to GCF it. The highest number that goes into this is 2. And the lowest exponent is x. When I do my GCF and I have one set of parentheses, don't forget your equal 0, and I divide this, I'm going to get x squared minus sign, and 98 divided by 2 is 49. Uh-oh, I see it. Do you see it in there? That little sniper hiding. Don't forget that this is a difference of two perfect squares. I've got a minus sign. I could take the square root of 49. And this is an even exponent. So that means that I'm going to bring down my 2x. Oh, yes. It's in equations. That's why we're doing them. And this is going to be x and x. Square root of 49 is 7 and 7. And you have a plus and a minus. All equal to 0. This is not the solution. This is how we get the solution. So we have it factored completely now. And now we're going to set each little factor equal to 0. So I'm going to have 2x equals 0. I'm going to have x plus 7 equals 0. And I'm going to have x minus 7 equals 0. And I'm going to solve each mini equation for x. That's going to give us 3 solutions. X cubed can have up to 3 solutions. We're going to divide by 2. 0 divided by 2 is 0. That's a solution. To solve for x, I'm going to subtract 7. 0 minus 7 is negative 7. That's a solution. And in this one, I have to add 7 to both sides. And x is positive 7. So this one has 3 solutions, or 3 roots, 3 x-intercepts, 3 zeros. They all mean the same thing. And this is a GCF combo with a difference of 2 perfect squares. Okay, so there's an example of that. So we have a regular GCF. We've got a GCF with a difference of 2 perfect squares. We got one more to go. Hope I have enough room. Do you know what's coming? Last one. Here comes our cubic. X to the third minus 8x squared minus 9x plus 72 equals 0. This one's got 4 terms. Do you know what to do with it? You got it. This is a factor by grouping. Got 4 terms. Factor by grouping. So we're going to crinkle cut right after the second term. GCF the left. What's in it? X minus 8. Let's do the right side. Oh, I need a minus sign. Check this out. I need a minus, and this is a plus. What do I have to do? I got to factor out a negative to make that negative match. So I have to take out a negative, and what's my highest number that divides into 9 and 72? 9. So negative 9x divided by negative 9 is x, and 72 divided by negative 9 is positive, I lied, it's negative 8. We need those negatives to match. Equals 0. We're almost there. With factor by grouping, I need to write what they have in common first, and I only write it once. Then I write the GCFs in another parenthesis and make another factor. Oh man, do you see it? Do you see it? Do you see it? A difference of 2 perfect squares, sniper. There it is. It's hiding in there. So I need to factor this again. I'm going to bring my x minus 8 down. This is a difference of 2 perfect squares. I need 2 sets of parentheses. Oh yes, this happens. It's pre-calc. It happens a lot. We're going to break up our x's. Square root of 9 is 3. And this is 1 plus and 1 minus. I have 3 factors here. Now I have to set each factor equal to 0. I'm moving up here on the side. X minus 8 equals 0. X plus 3 equals 0. And x minus 3 equals 0. All 3 of them are going to be solutions. This is a cubic. Cubics have at most 3 solutions. I'm going to add 8 to both sides of this guy, and that's going to give me x equals 8. There's a solution. Crosses the x-axis at 8. Subtract 3 to get x alone over here. X is negative 3. It crosses the x-axis at negative 3. That is a solution. This one I have to add 3 to get to the other side. x equals positive 3. There's our third solution. So this cubic has 3 answers, 3 roots, 3 zeros. They all mean the same thing. These are our places where our function or our cubic crosses the x-axis. See your teacher with questions.